And thank you for joining us today for the panel on AI and energy management. We look forward to the conversation. Just wanted to point out a few housekeeping things. The chat function and the Q&A function are both on your screen on either the lower level or to the right-hand side. Feel free to participate in the discussion, ask questions throughout. We are looking at 55 minutes for the entire panel, and we'll leave about 10 to 15 minutes at the end for questions from the audience. So really looking forward to that. So with the housekeeping out of the way, I would like to introduce the topic and our speakers. So the topic is the role of AI in energy management, pragmatic approaches. What is AI and what is it not? My name is Hannah Davis, and I am your moderator. I'm a senior research analyst at Guidehouse Insights, focused on AI and advanced analytics. We have three panelists joining us today: Graham Nasby, Dr. Ahmed Zamzam, and Dr. Joe Nayagan, who I'll introduce briefly. And if you want to check out their full bios, be sure to check out the agenda page on the World IIoT website. So Graham Nasby is an industry recognized leader in the water wastewater community for his efforts with distributed control systems and SCADA systems, standards developments, cybersecurity awareness, and alarm management. He is currently overseeing long-term planning, design, construction, implementation, and commissioning of an automated control systems for the City of Guelph Waterworks. Next, we have Dr. Joe Nayagan, who is a utility transformation and innovation advisor at SAS. He helps utility clients navigate the changing energy landscape and pressures of decarbonization, digital transformation, and decentralization. He has over 15 years of experience in the energy sector, ranging from energy modeling and decision analytics, energy economics and policy analysis, infrastructure investment, risk pricing strategies, and data analytics innovation. And finally, Dr. Zamzam is a research scientist, part of the Energy Systems Control and Optimization Research Group at the National Renewable Energy Laboratory, where he leads research efforts to modernize the US electric grid. His research contributes to a more sustainable, reliable, and equitable power grid for the future by utilizing AI technologies to automate decision-making and enhance real-time monitoring in the energy sector. So welcome to my panelists. To kick us off, I'd like to give you all, each of you, about 5 minutes to just talk about AI, how your company or the industry largely are using AI, and some of where you see the direction of the technology going. So we'll start with you, Dr. Nayagan. Joe.
Thank you very much, Hannah, for that introduction. So let me just set some context here. Now, with the advent of rising consumption of electricity from green supply generation sources, the electrical grid is transitioning towards a more decentralized system. Now, as we continue to electrify our entire energy environment, including transportation and buildings, the amount of electricity that is consumed will increase, and the complexity of that flow will dramatically go up as well. Now, this concern has led to what has come to be known as the grid edge. That is the intersection between the generation sources and the consumption side, which will need to be managed in a much more interactive fashion than we have done before or are currently doing. So the upside is that utilities will increase their productivity, new jobs are going to be created in the process, and the breadth and depth of the research and development in terms of the quality will also tremendously go up. Now here at SAS, where I work, I advise a number of utilities on how to navigate this terrain, looking at technical issues, market, as well as the policy transformation environment brought about by decarbonization, decentralization, and digitalization domains in the power and utilities industry. Now, our focus has been on innovation. Our motto is curiosity. And this is applied through application of advanced technologies. These solutions that we provide have machine learning and artificial intelligence embedded within. And you may ask yourself, why is this critical? This is critical because customer expectations and needs are constantly evolving. And the solutions that we provide to our customers will also need to evolve as well to keep up with this pace. But what we have actually noticed is that as AI has gained application in different use cases, in the energy sector, as well as in other industries, many people are focusing on the threats that it presents to privacy as well as security. But beyond these legitimate concerns, AI promises to optimize activities in terms of increasing efficiency and enhancing the accuracy and efficacy of the many aspects of our society that relies on predictions, as well as forecasting and optimization. In the energy sector, for instance, the rapid proliferation of distributed energy resources technologies like solar photovoltaics, energy storage, electric vehicles. We also have, a number of use cases that look at issues to do with microgrids and the intersections in between. Now, this offers the industry new opportunities for AI application. And with yet another new report that was just released this week by the United Nations, showing uncertain risk of climate change and the level of emissions rising uninterrupted, AI presents opportunities that we can harness in terms of creating new opportunities to accelerate a clean energy economy, but also looking at ways in which we can be able to bend the global emissions curve, particularly focusing on the energy sector in terms of addressing the climate change challenge. Energy management, the theme of this session, is one area which AI promises to play a critical role in terms of integrating demand side, as well as some of the supply side management strategies that are currently in play, and those that are also being developed by different organizations, different vendors, different national labs, as well as at the regulatory environment. Thank you very much, Anna.
Great, thank you so much. And I think next we have Graham. Oh, sorry, Ahmed.
Hi, thank you, Hannah. I work with the Energy System Control and Optimization, which is part of the Energy System Integration Group at NREL. And NREL is a national lab that is focusing on renewable energy development from technologies to integration with the power system. And in the Energy System Integration Group, we are faced with a large number of devices that are currently can be controlled or monitored in the operation of large energy systems. And just an urban energy system could contain tens of millions of distributed energy resources that are simultaneously producing or using energy. And we focus on developing scalable AI algorithms to forecast, control, and provide analytics for all these devices. We also create methods for independent system operations and to provide control methods without relying on models, which is something very hard to do with the complexity of the energy systems of the future. We also develop real-world solutions that can be deployed in real systems, and we help utilities deploy these technologies in real systems. Our work also concerns with energy system integration, which include increased grid flexibility by increasing connections and coordination with other energy domains, such as thermal, gas, water, and transportation. With the scale of the energy systems and the flexibility of the system in the future, AI represents a tool that we are harnessing to make the grid of the future more efficient and resilient, and make the decision-making it more efficient for these systems. And we are harnessing all these technologies to develop more solutions for the future. Thank you.
Fantastic, thank you. And Graham, go ahead.
Sure. My name's Graham Nasby, as Hannah mentioned. I work for City of Guelph Water Services. We're a public water utility located in Guelph, Ontario. For those familiar with U.S. geography, we're near the Great Lakes. I'm actually just across the lake from Rochester, New York, and about an hour inland. The utility I'm at, we provide water for a city of about 140,000 people. And one of the nice things with today's panel is we do have a nice mix. We do have Joe that's on the consultancy and service provider side of things. implementing in solutions around the world. We have Ahmed, who's on the research side, and then we've got myself, who I'm focused on the end user with sort of the hands on the ground of how we try to deploy some of these techniques that are coming up. Just a quick little bit more information about myself. Last 20 years, I worked in a number of different industries and roles. I did work in IT for about 8 years in enterprise IT. I was doing my engineering studies part-time at the time, and then I was in the engineering consulting community for about 10 years, finally joining Guelph Water in 2015. I think I'm helpful in some ways because I can provide a perspective of people who use energy, folks that distribute and produce electricity, and just sort of figuring out how you do this from an operationally side of things. The other things, I'm also involved with the Operational Technology Committee of the American Water Works Association, another committee with the Water Environment Federation, also known as the Wastewater Association, and some other committees with the IEEE, IEC, CSA, and a bunch of other acronyms, which are not all that important. But I'm really excited about IoT, Internet of Things. It has made many technology choices possible now that before were just so expensive that you couldn't do it. For example, I know of a nearby utility that has a data logging system they put together using a $35 Raspberry Pi as their data collector, which in older technologies, you'd be spending tens of thousands of dollars, and it was impossible for a smaller organization to take on analytics. Likewise, you also have the ways of gathering large amounts of data. So in a large organization, such as a national energy provider, they can now deploy AI or machine learning in ways that were just impossible to do. Even if they had the latest mainframe, it was just too hard to crunch all the data. So the area that excites me is that real-time demand forecasting is a really big deal. If you are an energy user and you can predict when you're going to need to produce more water, when you're going to have to treat more wastewater, or you're going to have to provide more of a service, because as a utility, that's a major win. That you can operationalize some of these tools, which have been traditionally only available in the management suite, you can bring it down to operations. Likewise, if you are an electricity provider and you are dispatching electricity for distribution or transmission, there's a huge area for opportunity when you're looking at when to do energy production orders or demand orders from a independent system operator of when to fire up generation and when not to, whether it's in conventional power generation or in renewables. A lot of that information was previously only available in long-term forecasting, whereas now it can be operationalized or brought down to the operations group. And with this IoT technology, we can put this on a dashboard or as a tool so the operations team that's in the control room can optimize their operations. So rather from doing a planning of operations, we can now execute in operations. And so I'm really excited about AI because it makes that easier to do, which even 5 years ago was very difficult. So I'll turn things back over to Hannah to get things started.
Okay, thank you, Graham. Thank you to the other two panelists. So the first question, I mean, just for a level setting, we see so many different definitions of AI, often including analytic process, human intelligence, making things more efficient. But in your mind, how do you define AI, especially for the energy industry? And Graham, since you were just talking, why don't you go first?
Sure, I would say AI is the intersection of big data, internet technologies, and the theory of neural networks and heuristic analysis. You put all that together with a lot of computing power and smart people, and some neat stuff comes out. That's what I see AI is.
Great. Ahmed or Joe, do you have anything to add to that?
Yeah, for me, AI is the development of a computer or a computerized way, automatic way to perform tasks that require usually human intelligence. And that is like visual perception, speech recognition, or decision-making that humans can do. And there is no better than an example to explain what AI is and how it is different. For example, in forecasting renewable energy, short-term forecasting, you can harness data from the history and information about other nodes in the system, and all these sources of data, blend them together, and using a machine learning model, predict what is going to be produced from this renewable energy source. And this is AI for me.
Great. And Joe?
Yeah, so I think embedded in the definition that Ahmed and Graham has given is what I call spectral recognition. And that is my definition of AI in just in 2 words. But from a historical context, the term AI was coined by John McCarthy, of Dartmouth College in the mid 1950s. So the question we have to ask ourselves is that why did it take more than 50 years for AI to gain prominence and growing application, particularly in the energy sector? And the answer to this question can be found in 3 other technologies that have unlocked the potential of AI. One is the Internet of Things, which has enabled sensorization of data as the number of sensors connected to the internet grew, thereby enabling greater communication and the rise of new data-driven services. And second is big data, which has allowed greater consumption and use of available data. And the third technology is the cloud computing, which has empowered us to execute complicated computations more economically. So for me, it is at the confluence or rather convergence of these 3 technologies that we have seen digital transformations manifest itself tremendously within the power and utilities industry.
Great, thank you. And in most of the answers, we referred to human intelligence. And a question from the audience came in asking, does IoT make humans more obsolete from the green jobs, or is it that IoT and AI are designed to help enhance or support the humans in their roles? So do you have any opinions on that? I mean, in my personal opinion, I don't think it's replacing, it's more of an enhancement, but I just wanted to hear what you guys think.
I'll jump in. I think it's a case of enhancement and enabling, to be honest, and enabling in a good way. Many times in organizations, we have people that know a lot about the operations. They know a lot about the physical plant or the assets, and they have intelligence on how to operate more efficiently, but they don't have the data or the tools to support what those are. So using AI and machine learning, you can take those hypotheses or ideas, push them into one of these systems and say, oh yeah, if we do X and Y, maybe we can save 10 or 15%. Maybe we can produce 10 or 15% more output. And I see it as a way of enabling. And yes, there are some jobs that will change. Some of the more boring jobs that people probably don't like doing, we can move them into more interesting jobs of where they're providing more or ROI instead of being seen as a cost center.
Yeah, for me as well, it is enabling and allowing for things to be done. For going back to the example of forecasting renewable energy, usually this was done in the past with looking at one weather model and using this to predict what is going to be generated. But currently we have the ability to use the computer to combine all these data sets, all these models together, which is something that cannot be done by a human, or it will take a lot of time. So it is enabling and giving more opportunities.
Yes, I agree with the 2 answers, expanding opportunities in the energy industry. And that is actually the contribution that AI is going to have tremendously in the utilities sector.
Great, thank you. Oh, okay. And our next question is, what opportunities do you see for AI technology for power utilities? I mean, there's so many, so I would be interested to hear your thoughts.
I can jump in. Like, I think now there is no question AI will be the brain of the future energy system, and technology continuously now collect and synthesize huge amounts of data from millions of sensors installed everywhere to make timely decisions on how to best allocate energy resources. In addition, we have advances in deep learning and neural networks, where machines can learn from their own and spot patterns and anomalies and analyze both demand and supply in the energy economy. The power utilities can use this data to predict what is going to happen in the demand side and then the generation side in the future. And this prediction allows for more efficient allocation of resources. And also this data can be used for control controlling and taking decisions on resources and operation of these resources, and used for monitoring, as we don't have currently models for everything that is operating in the system. We have to rely on this data to monitor what is happening and perform state estimation and assessment of the system. And lastly, this data can be used for planning or future planning of systems by looking at or assessing wear and tear of equipments and looking at these equipments, when do we need to replace them in the future. And for example, in the control, for example, we have historical data and feedback of interactions that can be used and adaptively to change the models that we are using to make decisions by interacting to the changes in the system in real time. And we can also, if we have models, we can learn what are the best models to use to control and operate systems.
I think AI also is going to give us some real opportunities in terms of how we manage how electric power is generated and scheduled. One thing that some of our viewers may not be familiar with, but the actual decision of when to spin up power plants and when to spin them down is primarily human-led. In the control system that are used in electric utilities, they'll have what they call a protective relaying system that is used to protect the system from equipment damage or overload. But the actual scheduling of when power is brought online and was not is primarily done by humans with a lot of experience. It's a very complicated system to run. AI has huge opportunities to provide an expert system analysis for the folks that are running it, or to even take over parts of the system to run it more efficiently. So that some of the problems that we've seen in the last few years, particularly early Texas situation we saw with the load problem they had earlier this year, AI could help with a lot with that and propose solutions than having to rely on protective relaying systems or some of the semi-blackout conditions that had to be done in order to preserve the system. Maybe AI would help with a solution for that, coupled with the big data that's available. The other thing to keep in mind is that the way these systems run is not just a technical thing. There's also a commercial aspect to it. I'm in Ontario, Canada. We have one of the most complex energy markets in North America in terms of how pricing is done. California is also very complicated, along with a number of northeastern states. AI could help both the system operator and the regulator figure out how to run those systems more effectively and more equitably from a commercial point of view. And I think there's some real opportunities both from the technical side and also on the commercial side for this technology to be applied for the benefit of everyone.
Great, thank you. And Joe, in your introduction, you were talking a lot about the enablers for AI and over the last 50 years, and you were talking about IoT and the rise of new data-driven services, and then also just greater data consumption. So I'm just wondering how we can leverage AI to support this digital transformation using even those three pillars and then other points, especially for the power industry as it progresses forward and more data is becoming available with more and more devices coming onto the grid. Oh, you're on mute.
Yeah, absolutely. Now, according to a study that was commissioned by Zprime, more than half of utilities that were surveyed in that study said that using IoT and AI in coordination was actually going to be very crucial in terms of enhancing long-term viability, success, as well as growth of the utility industry. And why is this the case? Now, IoT technology creates new opportunities for utilities to connect with consumers, digitize their grid, and transform the business. But these opportunities also present challenges, such as, for instance, the challenges that Graham was highlighting a few minutes ago in terms of how to use the influx of streaming data to enhance customer engagement, improve service delivery. So in order to build a cost-competitive business model that ensures reliable power generation, distribution, as well as delivery, utilities must improve the operational insights from a near real-time data perspective. And to achieve this, many utilities collect raw data from connected infrastructure and devices using industrial Internet of Things capabilities. And the volume of this data is growing rapidly. And we expect, tens of billions of IoT devices will be installed in the coming few years. Now, and we know that the current traditional approaches that has been applied in the industry in terms of helping with the data management and analytics may actually not be adequate in terms of helping us to analyze this new connected business environment. So to support this environment, utilities must be able to use analytics from both the traditional data centers all the way to devices at the edge of the network in order to analyze this data. Because simply collecting the data from connected sensors, meters, and systems is not going to be enough. Because from sensors that are connected on DER systems to phaser management units, we need a more agile and a flexible, integrated visual environment that can help utilities in terms of accessing, preparing, modeling, and visualizing, as well as deploying diverse IoT data. And this is actually the contribution that, in terms of capabilities, that AI is going to enhance in terms of analyzing this data, on a faster time frame, but also being able to analyze huge volumes of data within a shorter period of time.
Great, thank you. And so we're talking about the digital transformation. We had a question about what is AI's role in the sustainable energy transition? And then we had several other questions, and even in the chat, asking about hydrogen and power to X energy market, and how AI for monitoring trends and supply. How AI will be helpful in these new markets and overall the sustainable energy transition. I know, Graham, you mentioned the wind farms earlier and the Texas blackout example. So I'm just curious what your thoughts are.
If you're looking at renewables, every renewable technology out there has pros and cons. And when you want to look at hydrogen, there's two types of hydrogen. There's what they call green hydrogen, which is typically produced using electrical methods, either with a solar farm providing the electricity or wind generation. And then there's what they call blue hydrogen, which is an offshoot of the natural gas industry, because hydrogen does become available in some natural gas wells. So that each one of those has their pros and cons associated with it. I would say one of the challenges with hydrogen-based systems is transporting the gas is a little bit tricky. There are special types of tank which have to be used. We obviously don't want to have it like a Hindenburg type event happen, which wouldn't be good, of course. But then the technology's come a long way. But I think the important part is to look at what are all the pros from this. And if you're looking at from a triple bottom line point of view, yes, there's the commercial aspects to it, but what do we want to do from an environmental point of view? What are the benefits from this? What is the capital or environmental impact from using this technology? And what is the social impact from this? Is there a lot of infrastructure that has to be built? Who's going to pay for it? How is it going to be funded? And maybe AI might have a place in doing those models. Maybe we can feed all this stuff in, throw a big mainframe at it, or throw some cloud technology at it, and it'll come up with suggestions of how to model or set this up so it will financially and socially make sense.
Great, and Joe, Ahmed, do you want to jump in either about the hydrogen example or about just the transition to sustainable energy future using AI? Maybe with distributed energy resources and utilizing those and grid flexibility or something like that.
Yeah, I would like to highlight also most renewable energy sources such as wind and solar. They come with challenges, the variability of fluctuations that can happen and cannot be predicted. And usually when you have these devices installed, you have to have a strategy to handle this. And the AI basically can provide good predictions, good operational tools for operating these devices so that we can integrate more renewable energy in the systems. And by integrating more renewable energy, we can have a sustainable energy system and more greener energy system in the future.
Yeah, I'd like to add to that on the hydrogen question. Now, creating a clean hydrogen economy by using green hydrogen fuel produced from electrolysis with renewable or other low carbon energy sources to power vehicles is finally seeing a resurgence. And we see a lot of work being done in this area from research, funding, as well as policy standpoints. And blue hydrogen, which is mostly produced from natural gas with carbon capture and sequestration technology, is a cost-effective and has high technical maturity, because hydrogen can be produced, and used for propulsion in fuel cell electric vehicles, alongside other clean energy such as ammonia, synthetic fuels, and advanced biofuels. Hydrogen can also be used to power sectors that require very high energy dense fuels like air travel, long distance trucking, as well as shipping, which currently has limited opportunities for electrification. So if we are going to look at electrification of all things as has been proposed, then hydrogen becomes a very critical energy source in terms of helping us to achieve the electrification process. Now, clean hydrogen fuels can also be combusted to provide high temperature heat for hard to decarbonize heavy industries like cement, iron, steel, as well as chemical productions to support the industrial sector decarbonization policy. Now, hydrogen can also be converted to electrify the power sector when needed to balance, for instance, intermittent generation assets like renewable energy sources like solar or wind. And when produced from fossil fuels with CCS, a cost-effective clean hydrogen production process could also be realized that can help us in terms of enhancing our current production processes. So which are the main application areas that I see in the hydrogen area with respect to AI technology? I see AI in helping us to review different hydrogen use cases, for instance, distributed clean energy microgrids, grid resiliency, renewable integration, clean energy mobility from an electrical vehicle standpoint. I also see AI helping us to assess and recommend large-scale storage options for distributed hydrogen systems. The third area is in mapping existing natural gas pipelines, a grid which can be used to leverage hydrogen transport. And also the last one is in terms of advising us in terms of the role of flexible fuel generation systems in terms of bridging hydrogen future economy.
Great, those were a lot of examples, thank you. So moving on to actually implementing AI, say in a utility or in the power industry. Well, first of all, do you think that the energy domain is rich in data enough to support AI going forward? And looking at the public acceptance side of it, how do you feel about data privacy and how do utilities deal with that when looking at like customer data? So a question from the audience mixed with another one of mine, so apologize.
Sure, Hannah. I think we're getting there when it comes to electrical. So if we're looking at data from the substation side, from the transformer station, from the generation side, there have been a number of huge advancements in the protective relaying infrastructure in the last 10 years, particularly when it comes to protocols and way of timestamping data. Most substations now will have what they call an IED, or an intelligent electrical device, and it can real-time record amps and volts and watts and a whole bunch of other electrical characteristics, and that can be readily brought back over fiber optic networks or wireless-based networks or other way of bringing that data forward. And for folks that drive around, you're increasingly seeing on hydro poles, there's little white boxes showing up all the time now. And utilities are putting distributed instrumentation out so they can see how voltages are moving around, how currents are happening. The rural utilities in my area, you see a lot of monitoring of segments, which were previously what you call dark sections. You had no idea what was there. On the other side, on the customer side, we're now seeing more wireless metering. So we see smart meters being installed, and a lot of information about demand patterns can be gathered from that. And there are high-speed networks. And I think what's happening is this: we reach a critical density, and some markets are already there. This is the time where we can feed this into those IoT and AI technologies to provide that data and the historical data from databases that's collected over time. I think we're there in many of the main markets, and I think that's just going to increase over time.
Now, Ahmed, did you have anything to add on
Yeah.
the rich in data? Yeah.
Yeah, data, as Graham mentioned, comes from multiple sources, from utilities to smart meters, and also behind the meter data that comes with smart devices even installed inside buildings. And all this data comes at a different frequency, different accuracy, and usually using one data source is not sufficient to perform meaningful tasks or data analytics. So there are many efforts needed to combine and automatically integrate all these sources of data in order to benefit and realize the potential of AI technologies. And as you mentioned, there's some big concern about how to sharing this data, because the owner of this data initially is different entities. And there are multiple concerns about how to share this without compromising the privacy of the customers or compromising the security of the system itself. And there have been some efforts by DOE to provide data or to allow for data sharing protocols and mechanisms between entities, but this remains still a challenge. Another challenge is in data storage, because most of these devices record data and measure data with very high frequency, and this data accumulates over time. And one viable solution may be using the cloud, but there are also challenges with security that comes with the cloud. If you are uploading all this data to the cloud, how are you maintaining this? How are you ensuring that this data is secure on the cloud? So also some concerns to be addressed there about data storage.
Yeah, absolutely. And that actually brings me to one of my next questions about the opportunities and the challenges for using an on-premise versus a cloud-based or software as a service solution. I mean, there's two options that a utility or a power company can use for deploying AI, but I mean, both come with their benefits. And then also thinking of a traditional utility mostly are using on-premise, but do you see that changing, especially with AI and the mass amounts of data that is coming with it?
I would think reliability and uptime are two major things. So if you're looking at things from a safety point of view, something like a protective relaying system, obviously you're not going to put that in the cloud. That has to be on premise because it has to act immediately. But for data processing and AI and expert systems, this could be a really good opportunity for the cloud. And maybe you do it through a service provider, so you don't have to build this entire infrastructure yourself. You can engage a firm that specializes in this area, and maybe you can use part of an analytics suite or an AI suite that hundreds of utilities are part of, and so you can benefit from the economics of that IP being delivered where the cost is shared through all the users of that system. That could be a benefit. Whereas if you are a utility that's very remote, connectivity is very difficult, maybe you go with a less sophisticated system, it's on premise, but you don't have to worry about uptime issues depending on how you operate. But I think the cloud has some real benefits, but as Ahmed's mentioned, the cybersecurity part, you have to get it right. These aren't systems you want someone getting into, or as a friend of mine's IT says, you don't want someone making unattended backups for you, as in someone else getting access to data that they shouldn't have access to.
Right, Ahmed or Joe, do you want to add in here?
Yeah, let me just give an example, because at SAS, we are a technology provider. This is what we do. We help utilities to make, in terms of, we guide them through the process of making a decision whether they should go on premise or whether they should go on the cloud. And we offer analytics and AI solutions, both on premise, on the premises, as well as providing cloud services. And we have a flexible cloud solution that targets unique needs of the customers in terms of how to leverage as well as to unlock critical business opportunities with maximum uptime as well as minimum administrative overheads. This includes, for instance, providing software as a service offerings, which can be used to manage infrastructure, operating systems, as well as software. And the customers, simply sign up, log in, and get to work, focusing on the analytical challenges. We also provide managed application services where we help customers to design as well as manage cloud services and solutions. So in terms of deciding whether to go on premise or the cloud, the issues that Graham highlighted in terms of cybersecurity as well as budgeting constraints, those are issues that we have to discuss with a respective customer and then reach a conclusion that would be beneficial and meet the needs of the customer. So it all depends on, is a solution that is available, are you able to be host on premise, or would you consider the clouds? And then you have to consider the merits and demerits of those decisions, as well as your budgeting allowance that is provided for that. So it's a two-way process in terms of reaching that decision, but it's something that I think utilities, especially smaller utilities, municipal as cooperatives, they have to go through that process, because not all utilities have got open budgeting when it comes to investing in their IT applications. So it's something that we have to provide that advice. But I think the upside here is that we are able to enable utilities to have greater power and flexibility in terms of innovation with analytics, as well as the solutions that we provide either on premise or on the cloud.
Absolutely. And do you see the number of utilities investing in data science teams and analytics experts? Do you see that growing to match the interest and desire for AI in the industry?
Yeah, Graham, do you want to take that?
Yeah, I'll take that one, and I'm going to tag on to another comment you made a few minutes before. Yeah, I think it is. I think there's a business case for it there. There's some real wins that can be from a profitability and an operational effectiveness point of view. And as the business case has become easier to do by some of the forerunners in the industry, I think you're going to see it being worth doing that. Even 10, 15 years ago, having an energy optimization specialist in organizations was very rare, where I would be hard pressed for any medium-sized or large-sized municipality to not have a department that's looking at energy efficiency and having some full-time staff. And that was almost unheard of 10, 15 years ago. So there is the business case for it. The other thing I wanted to point out is all of us have raised the concerns about cybersecurity and keeping systems secure. So with AI, it can be deployed in the IT space. It can also be deployed in the operational or OT space. If you're looking at the IT side, there is a set of international standards for how to secure systems. They are with the ISO 27000 series. There's a number of very good standards there. In the electrical sphere, CERC has a very good set from the US government. There's some very good guidance in there. And then on general OT area, there's the IEC 62443 series of industrial cybersecurity standards, which are very good. And then also the ISC is currently writing a specific subset of that, which is meant for the electric power industry with some specific guidance. So there's lots of impartial, very high quality cybersecurity guidance out there, so that if you do want to implement something that's in cloud or hybrid or something in between, there's guidance on how to segment and protect your data to do these types of systems securely. And I would encourage you to look up those resources and engage an expert that can guide you through them.
Graham, I'm pretty impressed at how you just rattled off those standards and the numbers and everything off the top of your memory.
That's awesome, Graham.
Yeah,
everyone needs a hobby.
Okay, so besides SaaS and cloud-based or on-premise, what other infrastructure is needed, or what other prerequisites or pre-work is needed to happen before AI can be implemented for energy management or another application?
I think I would like to make a comment first on the on-premise versus cloud, and this is also comes with some limitations on both technologies. Like with when you have to implement an AI technology on-premise, there is limitations because processors or machines that can be installed on-premise can be limited in computational power, not like the cloud where you can implement very large AI models or machine learning models that can be trained with large amounts of data that may be not available on the premise if you are considering data from a single source. And back to your question about the prerequisites for applying AI. I think we need to have more data handling and cleaning and integration on the side of data, because data comes with different frequencies, data comes with missing data and corrupted data, and we need data cleaning procedures to integrate and make this data useful and readily available for the algorithms. On the algorithm side, I think we have many algorithms that are developed in industry, in academia mainly, and research labs that are basically assuming that the data is there, clean, easy to integrate, but this is not the case in real systems. So data handling and cleaning is one main thing that need to be handled in order to apply AI.
So Ahmed, just to reinforce your point about data, a really important thing, and this seems really silly, but it's timestamping. For these systems, the data points of timestamping must be accurate. And some of the data collection protocols used in industry, they don't do time synchronization. So you don't know if the timestamps are matching up. And if the timestamps are wrong, the data is garbage. It's no good. So some of the new IoT technologies have automatic timestamping in them. And there are some very good protocols, particularly DMP3 and 61850. These are substation relaying protocols are very good with timestamping. They do it automatically. But you've got to look at timestamping and also how real time is the data. Because a lot of these collection systems are designed to store up a whole bunch of data and then push it up once an hour. And depending on the type of AI you're doing, that may not be fast enough. You may need data coming in immediately. And how do you design those backhaul systems? How do you schedule the uptime? And lastly, about the clean data, all this instrumentation or all these sensors, they have to be calibrated and checked every once in a while. And when you go and check something, usually what you do is you take the value, you shove it all the way up as high as it'll go, you shove it as low as it can go, you put some test signals in it. And boy, if those test signals get into the AI system, the AI system's going to go nuts because it has no idea what's going on. So all these different things, I call them foundational things to get that data up into this expert system. There's a bit of work that has to be done there. And hopefully we can automate it because there's a lot of algorithms, but there's still that human touch. So, we're not obsolete yet. So don't worry. Judgment Day isn't coming yet.
Great. Well, so there are two questions related to the maturity of AI, and one that says, how soon are the common IoT machine learning applications going to move from being innovative, complex, and slow to adopt to being commodity, routine, and ubiquitous? So if you think about the time scale that we're on, where AI is in the industry now, how mature is it, and where do you see it in 4 or 5 years? Or I guess I should rephrase, when do you think it'll become this ubiquitous, easy to deploy instead of the 5 years thing? So opposite.
So I'll respond with a quick question, and then I'll turn it over to one of our panelists. If you told someone 20 years ago you were going to buy an electric car, what kind of response would you get 20 years ago versus today?
Very different.
I know, Joe, what do you think?
Never, because most people are not investing in electric vehicles because of concern to do with the range, and also the prices. The price was just too high to afford. So by the end of the day, it boils down to how is the technology going to help you to achieve the intended purpose for which you're seeking the technology for. And then the second is the price. Can you afford it?
Yeah, 20 years ago, I didn't know a single person with an electric car. I know 15 people that have them now, and they love them, and they've saved them a lot of money. So maybe that's a trend. Where's this technology going to be in 20 years?
Hey, but then you think about Joe in his introduction, he was talking about that AI was brought up in the 1950s, and it took, 70 years now to get to where we're just talking about these easy applications and the low hanging fruit. So, is it really in 5 years that it's going to become this ubiquitous thing that we're deploying everywhere?
With the large number of companies that are now leading and trying to develop solutions to be implemented right away in the systems, I see this is more of a 5-year thing than a 20 or more years. In 5 years, I think many of our homes will have these devices deployed, and it will be like a routine in our life.
Yeah, I agree, absolutely. The convergence of the technology, you're talking about cloud services, Internet of Things, and big data has really driven up this sector in terms of, application of AI technologies to different industries, but also the wide array of use cases that have emerged, where, AI techniques can be applied. There is actually no use case that I can think about at the moment in any sector where AI cannot be applied. It all depends on just the depth of the application and how, in terms of gaining deeper insights, to the extent that is being done, that is where you find a difference. But nearly all use cases that exist, be they in transportation, manufacturing, be they in retail or energy sector, AI has got very broad application, and the use cases are still growing.
Yes, they are. And we had some questions talking about use cases. I mean, we only have a couple minutes left, so unfortunately we can't get to all of them. But, thinking about how analytics and AI can help utilities reach this ambitious goal, of targeting 50% of EVs, talking about EVs. So potentially there's a way for AI to help with that progression of adopting EVs in the United States. So I just want to ask each one of you, what is your 1 to 2 key takeaways from either this conversation or recommendations for deploying AI or pushing it forward in the future? So Graham, I'll start with you.
Okay. I'll try to stay away from the cars one. I think the thing to watch is look at your organization is already collecting a lot of data. I would look at how are you collecting that data and how are you storing it. Make sure you're not throwing that data away. It's worth a lot more than you think. And look at the areas of where, if you had a better look forward, maybe that's an area where you can do a pilot project or look at a way to leverage some of that data you already have, or look at gaps of data maybe you want to be collecting so you're ready for when you want to give that try of that this new technology which continues to develop.
Great. Ahmed, would you like to go next? Key takeaways.
Yeah, we are not seeing many investments in AI at more of the investments in AI come from vendors and companies that provide solutions to utilities. As Graham mentioned, every utility now has an operational or optimization people, but the departments of AI and data analytics need to be larger than this in these utilities in the future. And I would again emphasize that now the complexity of what we are seeing in energy systems and the number of controllable devices and flexibility that we have require using AI to combine all these data sources and harness the power of AI. And thank you, Hannah.
Great. And Joe, last words.
Yes, Hannah. So you mentioned the electric vehicle and the latest push by the Biden administration to increase half of the US new car sales electric by the year 2030. So let me just say something about that, because I think this is a big deal, because this is actually, it targets the emissions, from the transportation sector, which is actually the sector that has got highest emission at the moment. Now, what we have to look out for with this kind of announcement is how much investment the administration is actually going to allocate to this sector, as well as some of the evolving regulatory environment and how this is going to shape out. Because AI solutions will play a critical role in terms of helping utilities to respond to some of the constraints that are going to be created as a result of rising load demand, as well as managing constraints both at the transmission and distribution level. But my closing word is that as we think about AI, the challenge for most organizations is that we tend to get into these drawn out pilot programs, which often stall out due to one reason or the other, ultimately not proving organizational value and also a loss in terms of the support from the executive. This phenomenon has become to be known as the proof of concept purgatory, which we have to be try to stay away from, because as we implement AI solutions, we have to guard against the pilot purgatory. And even in cases where, POC, so to speak, has been successful, utilities have still struggled in terms of coming up with value propositions that can be presented in terms of achieving the use cases that, they intend to roll out in different areas. And this, so in terms of the implementation, a combination of strategic intention, pilot management process, customer success, and quick execution will have to be looked at in terms of how to uncover the hidden roadblocks that exist in the AI in terms of the capability and how to accelerate the transformation in the energy sector.
Great. Well, Joe, Ahmed, Graham, thank you so much. This was really great conversation. And I will let everyone go. Have a great rest of your day. The next session is best practices for mitigating ransomware for OT and IIoT cybersecurity and energy and utilities. So thanks everyone for your time and have a wonderful day.